Good evening, ladies and gentlemen. Thank you very much for giving me a voice. Besides my invitation for lecture, I will today talk about uh, black bioinks from superstructure carbonized lignin particles. We will talk today about lignin possibility potential of being ink after special pretreatment, and thus replace lignin waste to become the material of which can replace synthetic fuel, because fuel originated fuel fossil fuel originated inks into more natural. The work is based on two articles. First article is the surface. It's based on work from 2022 written by Professor Rojas from Canada, from Aalto University in Finland, and surface energy properties of lignin particles studies by inverse gas chromatography and interfacial adhesion or in polyester composite with electromagnetic transparency and 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 uh, and work published recently with Professor Rokas from Finland in this year for advanced functional materials. Black bioins from superstructure carbonized lignin particles in advanced functional materials what less is for cellulose, and this is showing that how to produce. First, the production of nanoparticles is by using grafting, and nanocellulose is never it was coming the lignin from birch bark. Birch is very common trees. In case of uh, uh, of of reforestation is enough is thought to be, let's say, needed to be shredded because if too much will the forest will not go so fastly. So in many forests which we are cultivating forests for for wood industry and who need it. There needs to be birch. However, birch trimmed, and therefore is much lignin waste. And nanocellulose, therefore, to the countries with most wood exporter importer as Finland, is very important to find method to these ways to uh, to process and make some other components which replace the synthetic and will be more sustainable and green chemistry. And this is how it's nice. Nanosource is bleached and diluted in dionysus water and then homogenized. They defibrillated and then microfluidics, and then was mixed with lignosulfonate. Lignosulfonate as other components which comes to craft production, because craft production is separating cellulose using the strong acid, sulfuric acid, or really nitric or mixture with nitric acid and sulfides are preparing for making this waste naturally sulfonate. When we mix lignosulfonate with the non-cellulose particles, we get by cross-linking material which becomes similar, very useful. The material is used has high efficient pigment So 90, the material is, let's say, cross-link of this is a short optical band gap 1 to 1.5, and thus is not going to conduct light but absorb all light, so can be used as big black ink. If we lumo have more than 2 1, from 1 to 5, lower than 2 to 3 to 2, it can sometimes also subconjugated these polymers become semiconductor. But in this case, when we this support in this area, we're requiring for example, catching light and replace silicon and make a conjugate a polymeric photovoltaics, which is much more efficiency, more efficient than silicon. And this is very good idea because, but this here showed that these materials are very catching the light of 90%, making the viewing that is black. Black is absorbing all light coming, and therefore we get absorption of all light and getting black, which is more suitable for the pigments and the printing and nanometer. Therefore, this case was obtained, and the particle of this cross-linking in the this cross-linking was carried, and temperature in uh, the particles was in case of roughness, the cross-linking was taken in casting in UV treated glass of 50 milliliters, and this was in the reactors of cyclocollector of 100 Celsius and 0.330 megapascals. This was temperature was going to 2 centimeters per minute, and the residues. Then was homogenized and sheared at 10,000 rpm. Therefore, the preparation was going to then the last to form ink was to bath into ultrasonification. After bath ultrasonification, this material became the black solid ink. The viscosity was changed by rheology, by rheometer, and by consolidation and strength were made using texture analyzer and was scanned by microscopy, and X-ray was measuring the porosity and moving the mean height, which is showing how this can be for absorbing and roughness. Therefore, we obtain a material which was very good, obtaining to similar to traditional material and good absorbent properties. The lignin part, the intensity of Raman shift was 0.97, and it was very useful, and get relative frequency of absorb was much higher than normal with art. The carbonyl pink was absorbing most of light, so it was not slightly, so can be used as ink. So we have got the Professor Rojas showed the method of obtaining from lignin black ink with sustainable method. This is a part which with commercial using of black ink and over producing is very important due to make our daily life more sustainable. And this is showing one of the methods. Thank you very much for listening.